Hello, ladies and gentlemen. Welcome to Unit 7.6. So kind of what we're looking at is being able to graph polynomial functions, locate their zeros, maximums, and minimums, and kind of being able to interpret what those might mean. So kind of take a look at what we're talking about here. So an example, percent of the United States population that was foreign born since 1900 can be modeled by this polynomial. T is 0, and T represents 1900. So the graph is decreasing from 5 to 75. So it increases just a really little bit right here. Then from about 5 down to 75, it decreases. Then it changes direction again and goes back up. So it goes down here, up there, and it starts off going just a little bit up. So T is 5 and T is 75 would be considered turning points of that graph. All right, that's going to be kind of an important part here of when we're talking about parts of the graph. So we're talking about turning points in the graph. So a couple of things to jot down, just a couple of terms. The real zeros of a function are where does it cross the x-axis, okay? So y equals 0. So you've got x values, you've got y values. So where y equals 0, that's considered a real zero of the function. So a relative maximum is going to be where the graph changes from increasing to decreasing. So it goes, no other points or near it are higher. So if the graph kind of does something like this, this would be considered a maximum right around there, right? Regardless of what else is going on around it. So a relative minimum is kind of the opposite of that. A relative minimum is going to be if I've got a graph and it does, something like that, that would be considered a minimum right there. Okay, so maximum and minimums also called turning points. So you need to keep kind of that handy while you're doing it. So let's kind of get into it here. So we've got a polynomial function and it's gonna look like that. So now what we're trying to do is basically figure out all this information. So all I'm going to do is I'm going to throw this in the calculator and let the calculator do the legwork for me. So squared minus 4x minus 4. So x raised to the third plus x squared minus 4x minus 4. And once I do that, my table, I'm going to fill out my table first. So and it tells you right away that negative 2 is a 0. So I'm going to put a 0 right there. This ends up being negative 3.375. Then negative 1.5 becomes 0.875. Negative 1 becomes 0. Negative 0.5 becomes negative 1.875. And 0 is going to be at negative 4. 0.5 is going to be at negative 5.625. 1 is going to be at negative 6. 1.5 is going to be at negative 4.375. 2 is going to be at 0. And that's my graph. So now as I get this, I can start to use that to help me graph kind of what this is going to look like. So at negative 2, I'm at 0. At negative 1, I'm at 0. At 0, I'm at negative 4. And at 2, I'm back at 0. So when I look at this kind of gives me an idea of what I'm doing. Negative 2.5, I'm down here, 3.375. So it's going to kind of look like this. When I get to 1, I'm down here at negative 6. So it's going to come down here and then back up like so. All right, so that's going to be a sketch of what the graph is going to look like. So now what does that mean in terms of what we're dealing with? Well, keeping in mind the graph as I kind of fill in the rest of this information, zeros are where does it cross the x-axis? So that's easy. That's negative 2. That's going to be negative 1. And that's going to be 2. And they give me 2 as one of my options up above too. And they tell me right in the problem, that negative 2 is an answer. So my maximum then, my relative maximum is actually going to be right there. Okay, right there, that's going to be my maximum. Notice that is the highest point around it. Okay, it's also a turning point. It stops going up and starts going down. All right, so my maximum is going to be right about here. So I'm going to say that's 0.875 at negative 1.5. So that's going to be what that looks like. That should, I want to draw a better 5 than that. There we go. So my minimum is going to be down here. Here's my other turning point. So I'm going to say my minimum is going to be at negative 6, and that's going to be where x equals 1. All right, so I'm looking for a high point, looking for a low point. End behavior just kind of looks at the far left of the graph and the far right of the graph. And here's kind of what this says. As x goes towards infinity, so as this graph goes this way, what happens to my graph? Well, as I go this way, this graph keeps going up, up, and away. So that's what I say. As x goes towards positive infinity, the function goes towards infinity as well. This means as x goes towards negative infinity. So as I go this way, then I'm going to keep going down like so. So I'm going to say towards negative infinity, because this is going to keep going forever and ever and ever and ever and ever in that direction. So there's a couple things you got to keep straight. You've got to figure out where your zeros, maximums, and mins, and then what is your end behavior. So it's very, very important to keep a good graph to start with. Okay, so keep that in mind. So now as we go here, we've got this function x raised to the third minus 4x squared plus minus x plus 4. Given that 4 is a zero of the function, so 4 tells me right away that that's going to be one of the zeros. Find the other real zeros, find the relative maximum, relative minimum, and describe the end behaviors. So I'm letting my calculator do a lot of the work, so I'm kind of filling that in from there. So as I graph this, negative 1 is going to be 0. 0 is going to be at positive 4. Negative 2 is going to be way down here at 18, negative 18. So this is going to take off down in a hurry. At 0, I'm at 4. At 1, I'm back here at 0. At 2, I'm down here at negative 6. And at 3, I'm down here at negative 8. But at 4, I'm back up at 0. All right, so I can start kind of getting an idea. And by the time I get to 5, I'm all the way up at 24. So I'm starting to get kind of an idea of what this graph is going to look like just by plotting those points. So it's going to look something like that. And obviously, the more diligent you are with your graph, a lot easier these questions are going to be to answer. So going off our graph, so where are my zeros? Well, I've got a 0 here, here, and here. That one we already knew about. This one we already knew about, the one that said 4. They told us about that already. So my other ones are going to be negative 1 and positive 1. So my maximum, I would say it's going to be right there. Okay, I would say that's going to be 4, and that's going to be at 0.0. My minimum is going to be here. That's my other turning point, and that's going to be at negative 8, and that's going to be when x equals 3. So now, end behavior. Again, as x, goes this way. As my graph goes out, what is my function doing? It's going up, so that means I put positive infinity. As x goes negative, my graph is going down, so I say it's going to be negative infinity. That's my answer. So that's all I'm looking for, positive infinity and negative infinity. So if I take a look here, new function. By the way, if you want me to help you program these things into your calculator to make life easy on yourself, I'm more than happy to do that. Just let me know, and I can show you some tricks that are going to make your life significantly easier. Minus 4x squared minus 4x. Okay, and they tell me that negative 1 is a 0, which is helpful. So, just graphing this, oops. Just graphing this, I'm looking and I'm going, well, negative 2 I know is a 0. Hey, negative 1 is also a 0. 0 ends up being a 0. 1, I'm down here at negative 6. 2, I'm back up here at 0. And by 3, I'm all the way up to 60, so I'm off the graph. So if I keep coming left here, negative 2, 0, negative 3, I'm back down to 30. So at negative 1.5, I'm negative. Negative 1, 0, negative 0.5, I'm at 1. So it's going to end up being something like this, to where I come down, switch directions, come down, and take back off like that. So my graph is going to look a little bit like that. So I've got to be careful here. So my zeros, well, they told me that negative 1 is a 0. So I've got negative 1, I've got 2, I've got negative 2, and 0 are all going to be zeros. All those places where it crosses the x-axis. Now my relative maximum is right there. Okay, I'm going to say that that's going to be about negative 0.5 is where it's located, negative 1/2, and it's 9375. But if you were close, if you put close to 1, I wouldn't count it terribly wrong. So that's going to be my maximum. I've actually got two minimums here. One is right here, and one is right here. So we'll do the easy one first. I'm going to have 1 at negative 6, and that's going to be at 1. My other one is going to be at negative 1.5, and it goes just a little bit bigger than negative 1. So it's actually 313. So that's going to be at negative 1.5. Now, this one's a little bit different as far as end behavior as well. So as x goes towards positive infinity, so as my graph goes this way, what does the function do? It goes towards positive infinity. As x goes this way, what does the function do? It goes towards positive infinity again. The last couple have gone different directions. This one both goes towards positive infinity. So you've got to be able to find zeros. You got to find maxes and mins, and you've got to describe the end behavior. That's kind of the big topics we're talking about here. All right, so that's kind of what you're going for. So last problem, the average fuel consumed by individual vehicles is this. So where T is the number of years since 1960. So 10 years is 1970, 1980, 90. This is 2000, way over here. So the maximum average fuel consumption, and give the year that it occurs. So the maximum, I'm ignoring this part over here. I'm looking right about there. And I'm going to say that that is about 1967. Not 1667. That was a long time ago. 1967. And I would guess that it's probably around 715 gallons, roughly. And then for the minimum down here, that's going to be quite clearly right here. So that's going to be 1990, I would say 1995. And that minimum is going to be just below 525. So I'm going to say that it's approximately 520. So this is approximately 715. So that's kind of what you have to be able to do for this section. If you have any questions, please come talk to me, especially if you want to look at some of the calculator work. All right, have a good day. We'll talk to you soon.